particle has acceleration a is equal to 2t4 meters per second squared for t greater than or equal to 0. The particle is initially at the point with position vector 2I minus 2j meters and travelling with a velocity of negative I plus 3j meters per second. Now, these are going to be important for constants of integration. We want to find an expression for the velocity of the particle at time t. So we're going to integrate. So integrate 2t, we get t squared plus a constant. Integrate 4, we get 4t plus another constant. And we know that v of 0 is equal to negative 1, 3. That's given to us just here. So since t squared is 0 when t is 0 and so is 4t, it should be clear that c1 is negative 1 and c2 is equal to 3. And therefore the velocity is going to be t squared minus 1 and 4t plus 3. We now want the value of t greater than 0, when the particle is travelling parallel to the y-axis. So if it's travelling parallel to the y-axis directly up, that means the horizontal component needs to be equal to 0. Therefore, t squared minus 1 equals 0, t squared equals 1, t equals positive or negative 1, but it only works for t greater than or equal to 0. So t is equal to 1 second. Explain why the particle can never travel parallel to the x-axis. Well, to travel parallel to the x-axis, that would mean the y component of velocity would be equal to 0. And 4t plus 3 is not equal to 0 for any t greater than or equal to 0. We now want to find an expression for the displacement of the particle at time t. So we've got the velocity up here. We're going to need to integrate that again. So r is going to be t cubed on 3, take away t plus a constant, and 2t squared plus 3t plus another constant. We know that, that's the one we want, the displacement. We know that r is equal to, that was 2 negative 2 when t equals 0. So when t equals 0, everything here that's a function of t is 0. And that tells me that c3 is equal to 2 and c4 is negative 2. And so we have r is t cubed on 3, take away t plus 2, and 2t squared plus 3t, take away 2. We now want the time at which the particle crosses the x-axis. Well, crosses the x-axis means y is 0, and therefore 2t squared plus 3t minus 2 is equal to 0. That gives me x plus 2, not x, t plus 2, 2t take away 1 equals 0, which means t is negative 2, and of course that's not possible. T has to be greater than or equal to 0, or t equals a half. We now want the displacement of the particle when t equals 3. So that's just r of 3, which is going to be 3 cubed, 27 divided by 3 is 9. Take away 3 plus 2. and 3 squared is 9, so 18 plus 9 take away 2. So that is going to give me 8 and 25. We want the change in displacement in the first 3 seconds. Well, r of 0 was 2, -2. r of 3 is 8.25. So the change in r is going to be 6.27. And then finally, we want the distance travelled in the first 3 seconds. And we can do that in various ways, but one of the ways that we can do it is the integral from 0 to 3 of the modulus of v of t dt. Now, v was this. So the v was t squared minus 1 and 4t plus 3. So that is going to be the integral from 0 to 3 of the square root of t squared minus 1 squared plus 4t plus 3 squared dt. And we can just calculate that on the class pad. And doing that gives me 28.27 meters. Now this really is the way that you have to do this, because unlike when we had particles just going along on a straight line, it's very difficult to figure out changes of direction, and of course it might be doing a curved path, indeed is doing a curved path. So the integral is the way to work out the distance.